Okay, have everyone. So we're gonna start the content after midterm by looking at differential equations. And today it's gonna be the class that we talk about how to solve differential equations. We're gonna show you some examples today, but you can work on more example in the clips that I post before midterm, the 6th clip about differential equations. But today we're gonna do some examples to give you the idea of what you're gonna learn. So when you watch a clip, it's gonna be easier for you to watch. The idea is that today we're gonna just trying to go over all differential equations, the thing that you're gonna learn, and what you're gonna be tested on differential equation is gonna be the take-home exam, which is called exam 3. It's gonna be 10% of your grade. It's gonna be take home. You can open notes and open clips. It will post on April 5th and due on April 12th. So basically, you don't have to be super serious about memorizing the technique because you can open notes on the take-home exam. So it's gonna be just listen and trying to understand step by step how to solve differential equations, and then that's all you need for this chapter. And then once we're done with this differential equation, next week we're gonna come back and work on limit, continuity, differentiation, and integration of function of two variables. Okay, any questions so far?
So the exam 3 only include the differential equation or also the vectors?
Only differential equations.
Okay, thank you.
ครับก็คือ this one we're gonna just have as you know that we're gonna have the final exam on differentiation and integration with function of two variables. Okay. All right, so let's start by taking a look at what you need to watch in the clip. So in the clip you're gonna have 6 clips. So number 1 gonna be intro to differential equation. Number 2 gonna be separable equations. Number 3 is homogeneous. Number 4 is exact differential equation. Number 5 is integrating factor. So the full clip you're gonna see the minutes here. This is the length of each clip. The last one gonna be linear and Bernoulli differential equations. If you have time, you can take a look 40 minutes about clip number 6, but usually we're gonna test you on clip number 1 to clip number 5. So make sure you look at more example on these clips. So it's gonna be the one that you can watch it by yourself. But today we're gonna go over everything as well, but we're gonna just trying to do examples so you have a background before you actually go to watch the clip. Okay, so first of all, what is a differential equation? So you can imagine that in real life you're gonna have something that is the equation that it's come together with the differentiation and normal x and y. For example, like before you could have like y equal to x squared plus x plus 2. This is just standard equation, right? This is the standard equation. And then if I say that, oh, let's suppose that you have x squared plus x plus 2 equal to 0. This is a standard equation that you can solve for x. And it's gonna be the quadratic equation, and then you can solve for x. But for the differential equation, it's gonna come with dy by dx in your equation. Something that you have dy by dx, for example, equal to x plus y. For example, this is the differential equation, the one that you have x and y. together with dy by dx in the same equation. This is called the differential equation. And then you can learn some technique how to solve it. So the first technique gonna be separable equation, which we are going to do in few minutes. First of all, you have to understand that the solution for the differential equation is gonna be a function. So when you solve for it, it's gonna give you a function. Okay, let's try to do it, everyone. So first of all, we're gonna do, first of all, you solve separable equation here. If I give you a differential equation here, I want you to solve for the solution. Keep in mind that the solution that you're gonna get, the solution that we're gonna get is a function. So you need a function as a solution. So the solution is not a number, it's gonna be a function. When you solve for it, it's gonna be the function y equal to something. This is what you are looking for the solution. So first of all, we're gonna learn how to solve separable equation. Separable equation is the equation that you can move x and y separately on each side. So if you have separable equation, you can simplify it, and at the end you're gonna get the equation that you separate x on one side and then separate y on another side. For example, if you have dy by dx here equal to e to the 3x plus times 1 plus y squared over y plus 4 here, you can simplify it by moving x to one side and moving y to another side. So we're gonna start by simplify. I move y plus 4 here to the left, and then I move 1 plus y squared to the left, and then I keep dy here, and then I move e to the 3x, stay there, and then dx here. Can you follow that? It's just trying to move dx to the right hand side, so dx is here, and then I move this term 1 plus y squared over y plus 4, I move it to the left, so it's gonna be y plus 4 over 1 plus y squared. Does it make sense? So if you move everything around and then you see, oh, we have x on one side, we have y on one side, separately you can see that you have no y here, you have no x here, and then after that you integrate on both sides. This is going to give you the solution, and then once you integrate it, so you're gonna get the answer for the separable equation. So we're gonna integrate the right hand side first. Integrate e to the 3x dx. What is this one? So it's gonna be e to the 3x, and then you multiply 3, because this is by the chain rule. Before that, use substitution. You remember that? Okay, I always do it 3 times e to the 3x here, but if you cannot remember, it's gonna be here, and then you pick u to be 3x. That means du gonna be 3, and then this is actually integrate e to the du over 3, and that is 1/3 time, oh no, sorry, this is not correct then. So u here, and then d 3x, and then 3 here, so you get 1/3 e to the u plus c. So it's actually 1/3 e to the 3x plus c. So basically here you're gonna have 1/3 e to the 3x. Does it make sense? For this term, this is just the integration one. So take your time when you do the, when I give you the take home exam, you can just open notes, look at the function, how to integrate this one. So you have 1 week to do it for 5 questions. So you can just trying to integrate this function, and then on the left hand side you integrate this one. So you're gonna, this one is hard to integrate, right? Because you have to split it in 2 terms to be easier. So you can split to y over 1 plus y squared. This is the first one. And then you can split to 4 over 1 plus y squared dy, right? You just separate it different in 2 terms, so it's easy to integrate now. So I'm gonna keep this one first. I will integrate at the same time. And then you integrate on right hand side, you get this. And then on the left hand side, so here you're gonna get 4 times arctan y, right? Because this is a formula for arctan, like integrate 1 over 1 plus y squared dy. This is arctan y. And then this one you have to pick u another time. So this is my scratch word. And then you can do another one. So you integrate y over 1 plus y squared dy here. You can have integrate 1 over u du over 2y, right? Because you pick u to be 1 plus y squared. So once you pick u equal to 1 plus y squared, du by dy, it's gonna be 2y. So which means you change 1 plus y squared to u, and then dy gonna be du over 2y. And then now you're gonna have, oh, not 1 here, it's y here. And then y gonna cancel out. So y cancel y. So you're gonna get here 1/2 integrate 1 over u du, which is 1/2 times log absolute u plus c. So basically, once you integrate that with thing on sketch work, so you know that it's gonna come back with log absolute 1 plus y squared. Because 1 plus y squared is always positive, you can do the soft bracket now. And then you plus c on one side. You actually can plus c1 here, plus c2 here, plus c3 here. But anyway, it's going to group up to b1c, so it's fine. So you can plus c at one time at the end. And this is the solution for the separable equation. Does it make sense? You're going to see 4 more examples in the clip that we're trying to do separable equation here. And this is going to be the first question on the take home exam. So just trying to move everything around so you get separable equation, and then you integrate separately on both sides. You can solve for c here. Sometimes they're going to give you the condition that you can solve for c. Let's do question 2. So we're gonna just, when you stop, you can stop here. This is the answer. If you want to double check this is correct, you can try to differentiate this function. It should be this one. But I mean, no one's do it because it's like take time to differentiate this one so you get back this one. Because this is a function that when you differentiate with respect to x, you get this one. You already solved for it. This is the separable equation. Does it make sense? Alright, so let's do question 2. We want to solve the initial value problem, this one. But this time I give you y0 equal to 1. When I give you y0 equal to 1, this means when x equal to 0, y equal to 1. This gives you that when x equal to 0, y equal to 1. You solve it first, and then you plug in x equal to 0, y equal to 1, and you're going to get the solution. So this one, well, first you move 1 minus 2y squared to the left, and then over y, and then dy. And then you move x to the left, or to the right hand side, you get cosine x dx. So separable equation is easy in terms of you can move x to one side, move y to one side, and there is no complicated terms on the left and on the right, so you can integrate on both sides. Shoop, shoop. And then integrate cosine, you get sine, right? But before that, so let's split the first on the left 1 over y dy, and then minus 2 integrate y dy. You follow that? Like I split y here, cancel out, so I get integrate 1 over y dy minus 2 integrate y dy. And then on the right hand side, I get integrate cosine x dx. And after that, I integrate everything, so I get integrate log y, so integrate 1 over y, I get log y, absolute y. And then integrate y dy, so I get 2y squared over 2. Remember, integrate y, so you're gonna get y squared over 2. And then integrate cosine, you get sine x plus c. Okay. And this is the This is a thing you call general solution. General solution. But when it's come to the initial value problem, you're gonna have the condition here. So you can plug in when x equal to 0, y equal to 1, and then you can solve for c. So we can solve for c by using y0 equal to 1, okay? Which means you plug in everything, so you're gonna get log absolute y is gonna be 1, y is gonna be 1, so this cancel out, y is gonna be 1, and then x equal to 0, so psi 0 plus c. So once you plug in x equal to 0, y equal to 1, you can solve for c. Log 1 is 0, e to the 0 is 1, and then minus 1 equal to psi 0 plus c. Psi 0 is actually 0, this is 0, so actually c equal to negative 1. Okay, and then now it's come back to the solution. Now the solution gonna be log y minus y squared equal to psi x minus 1. This is the specific solution. Specific solution. So you solve for c after that. It's gonna be this one. Looks pretty simple, right? Just this is a separable equation.
So there are more, I think.
Well, we do expect you to like get full credit on this take-home exam because you have 1 week to do it. And then you can double check with the so many times that you integrated correctly, and then you solve for c correctly. This is the way that we solve separable equation. More example will be on the clip here. So for those of you who want to work on it, more example, it's gonna be only 15 minutes to talk about separable equation. So the way that you're gonna do is you go to my course view. This is another class, no. But you go to my course view here. You go to playlist, and then you're gonna see the clip here. Clip here. But well, the first clip, introduction to differential equation, is going to be just intro what is differential equation. You don't have to be worried. But it's gonna start the content on separable equation, which is clip number 2. So I'm gonna show similar question to question 1 and question 2. You're gonna look at how we solve separable equation in 15 minutes. You're gonna see more example. Does it make sense?
Yes.
And then clip number 3 gonna be homogeneous differential equation. So we're gonna take a look at homogeneous. So I give you example. So when you watch a clip, you have more example. Okay. So there's gonna be 1 question on separable on the take-home exam. So make sure that you learn how to move everything around, separate x and y, and then you solve for it. All right. So homogeneous equation. Let's talk a little bit about homogeneous differential equation. Homogeneous differential equation. So what it is? So homogeneous differential equation, you start from the form of differential equation mxy dx plus nxy dy equal to 0. So you simplify, so you get this one, and then you have to check first that m and n here, they are both homogeneous function. So the way that you're gonna check it is homogeneous, you can check by doing mtx ty. If you can simplify it to t to the n mxy here, it's gonna call homogeneous. Ntx ty, you plug in tx and ty inside there, and then if you get t to the n nxy, this is also homogeneous. it's gonna be homogeneous with the same degree, degree n, degree n. This is the degree that you can pull out your n here. And then once you show that m and n are homogeneous, so the way that we're gonna solve it, you're gonna do step number 1. You're gonna let y equal to vx. Once you let y equal to vx, you're gonna have dy equal to v dx plus x dv. And then everything gonna turn to separable equation, and then you can solve separable equation. So step 2, change everything to x and v, and everything gonna be separable equation in terms of x and v. You will need to solve separable equation in terms of x and v. Alright, let's see if you can do it, but we're gonna have example to show you how to do it soon. But when we want to do homogeneous differential equation, first of all, check first m and n. They are both homogeneous, degree n. And then after that, you do step number 1, define y equal to vx, and then you get this one. And then step number 2, you're gonna get this one. Once you see example, you're gonna be more clear what I mean by checking the homogeneous and then do the chain of variable. Okay. All right. Let you jot down for a minute, and then we're gonna do example on homogeneous differential equation. All good? All right.
This method of solving the homogeneous differential equation can apply for all calculation for the homogeneous one.
This one you can apply if you know that the equation is homogeneous. You can do it. It's guaranteed that it's gonna go to separable equation at the end. Okay, let's go. So we're gonna do question 3 here. Show that the given differential equation here, this is homogeneous, and then show that the solution of this one is this one. So we're gonna start by having y square minus x square dx plus xy dy equal to 0. Okay, this is your equation. And then this is actually your m xy. This is actually your n xy. Okay. M here is the one that I highlight in green. XY here, this is n, the one that I highlight in orange. And then now you're gonna do, first of all, you're gonna do mxy. This is actually you plug in t first, so it's gonna be mtx_ty. So you plug in tx and ty inside the function m. So you're gonna get tx ty square minus tx square equal to t square y square minus t square x square. And then now you can pull out, you're gonna get t square y square minus x square. So this is actually t square m xy. Does it make sense? So the idea is that we're gonna plug in tx and ty here. So we wanna see that if we plug in tx and ty, you can pull out t to the something or not. So we plug in t here, plug in tx ty here. So I can pull out t square. So it's gonna be mtx ty equal to t square mxy. This means m is homogeneous of degree 2, right? Because it's actually homogeneous because you plug in here and then you get t square. And then you hope that when you do it, the same thing with n, you're gonna have the same degree. n tx ty. So you plug in, it's gonna be tx times ty, because by the definition of n, so it's gonna, when you plug in it, it's gonna be the first multiply the second, so it's gonna be tx multiply ty here, and then that is actually t square xy, which is go back to t square nxy. So same thing, n is also homogeneous of degree 2. Okay, and once you have m and n, they're both homogeneous of degree 2. Now you can conclude that the differential equation, then the differential equation is homogeneous. Once you know that the differential equation is homogeneous, you're gonna go back to our 2 steps. So step number 1, you let y equal to vx, and then you switch everything in terms of x and v, so it's gonna be separable equation, and then you can solve for it. Alright, so now we're gonna show you how to do the homogeneous differential equation. So we're gonna carry the equation and then switch everything into x and v. Alright, let's go. We have this one. Copy this. Alright, and then now we're gonna we let y to be vx. So what happened is, once you let y to be vx, it's mean here you're gonna have vx square minus x square dx, and then plus x vx. Dy here, you're gonna need to differentiate y by product rule, so you're gonna get v dx plus x dv. This is just by the product rule that you learned before, and this is actually v dx plus x dv equal to 0. You can see that what I did here is I just replace y by vx, I replace y by vx, I replace dy by v dx plus x dv. This is what I just did. So basically I turn everything into x and v. Okay, and then now you simplify it, so you're gonna get v square x square minus x square dx, and then plus vx square, and then v dx plus x dv. You hope that something gonna cancel out, or something gonna be good for you to simplify until you get separable equation. So let's see if you can get something like that. So you're gonna have v square x square dx minus x square dx. So, and then here you're gonna get vx square, v square x square dx plus vx cube dv equal to 0, right? Well, this is claimed to be the separable equation already, so you're trying to move x to one side and then you move v to another side. So you can see that this is actually dx, so we're gonna group this thing on the left hand side, and then we're gonna move dv to the right hand side. So I'm gonna but this term and this term, they are the same, so we're gonna say this is 2v square x square dx. We have that 2 term minus x square dx, and then equal to, so I group these 3 terms together, so I'm gonna have this and this together, so I get that, and then this I move to that one, and then now the right hand side gonna be minus vx cubed dv. Okay, I move this thing to the right hand side, and then now, well, the idea is you're trying to move v to one side, move x to another side. So the idea is we're gonna save everything in terms of v to the right, we're gonna save everything in terms of x to the left. So let's see if we can do it. So we're gonna pull out on the left hand side dx, and we're gonna have x squared times 2v squared minus 1. Can we? Like on the left here. Because we can pull out x squared first, so you're gonna get 2x, pull out x squared, so you get 2v squared, and then minus 1 and dx. On the right hand side, you're gonna have minus vx cubed dv. So I'm gonna move x to the left, so I have x squared over x cubed dx, and then on the right hand side I have minus v over 2v squared minus 1 dv. Good now? It's just like take a lot of time, you can see, to simplify it, because this is the point that I give you this part to be the take home exam, because if you do it on the real exam, on the final exam, it's gonna take like at least 10 minutes per one question, because you need to simplify a lot. So this time you have a week to do it, so you can just keep simplifying if you want to, and then like you simplify here, you're gonna get 1 over x dx. You know how to integrate it now, and then on the right hand side you're gonna have minus v over 2v squared minus 1 dv. So you integrate on both sides, integrate. Now you need to integrate it. Okay. Alright, keep going. So we're gonna do it here. So integrate 1 over x is log absolute x, right? Okay, we need to integrate this term first. We need to integrate this term. So let's try to integrate that one first. So scratch work. So we want to integrate v over 2v squared minus 1. How could you do it? So we're gonna pick this to be d2v squared minus 1. So it get 4v. Is that way too fast? I know some of you cannot follow that one, so we're gonna just go slower. So we're gonna let w to be 2v squared minus 1. So dw over dv, it's gonna be 4v, right? And then here you're gonna have dv equal to dw over 4v. So this is actually integrate v over 2v squared plus 1 over dw over 4v. And then now you cancel out here and here. So you get 1 over 4 integrate 1 over w dw, right? Because everything is in terms of w now. So it is actually 1 over 4 log absolute w plus c. Which means when you go back to the red one, so you're gonna get log absolute w, log absolute x equal to minus 1 over 4 log absolute w plus c. Well, I'm gonna just keep going on the next page. Let me jot down first. So I'm gonna move to the next one, but need to copy that. Okay, and paste it here. This one, it is the integrate from calculus 1. If you feel like, this is way too fast, you can go back to calculus 1 when we learn substitution rule. We just switch the variable, do the substitution, so you get this one. This is actually 1 over 4 log absolute w plus c. It's gonna be on your right hand side. On your left hand side gonna be 1 over x. So this is actually on the left, you're gonna have log absolute x. On the right hand side, you're gonna get 1 over 4 log absolute w, which is this one. This is actually the general solution already. But your v is actually y over x, so you can change it back to y over x because you let y equal to vx at the first, so v is actually y over x, so you can change v back to y over x. And then this is the answer for general solution. You can simplify until you get the term that they ask you here. You can actually if you want to. But up to this point, this is called general solution. This is a tedious one to do it because you can see that even like just one differential equation, it take you 3 pages to do it because you just need to change variable and do this thing a lot. Do the simplification. Okay, you done? Good. So อันนี้เหรอ
ใช่ครับ
Okay, so this is called homogeneous differential equation. What you should do after here is like you go to the clip number 3, homogeneous differential equation, and when you watch the clip, there are gonna be more examples on this one. You can see that one example in the clip gonna take 2 or 3 pages, so it's gonna be the long one. But basically the idea is you trying to check first the solution, the equation is homogeneous, and then after that you switch y equal to vx. It is guaranteed to be separable equation in terms of x and v, and then you solve for x and v, solve for the solution for separable equation, then the answer gonna be just there. This is the homogeneous differential equation. Does it make sense? All right, so we're gonna check one more question 4 here, and then we're gonna have a little break for you. And then we come back, we're gonna learn about 30 minutes more. So for the homogeneous equation here, x times dy by dx minus y times x cosine y over x.
What is this?
I tell you immediately that this is homogeneous equation. So basically you just need to simplify first until you get m and n, and then you do the homogeneous differential equation. So first of all, we're gonna start by move y to the right hand side. So I have x dy by dx equal to x cosine y over x plus y. Right? I move y to the right hand side. And then now I have x dy equal to this thing everything here dx, and then now you have x cosine y over x plus y here dx. This is actually minus x dy, or you can say it is plus negative x dy equal to 0, right? This is what you simplify. Once you simplify it, so this is actually your m. This is your mxy. And then you simplify it already. This is going to be your nxy. Okay, so you have the green one, that is your m. The blue one, that is your n. And then now you check that they are actually homogeneous. So mtx ty, it is actually tx cosine ty over tx plus ty, right? And then you plug in, you can see that the one I highlight in green, that is the function m, and then I plug in tx and ty. I plug in that, so I get back tx cosine x over y plus ty, because t gonna cancel one time. And then now you can pull out t, so it's gonna be t times x cosine x over y plus y. Oh, y over x. Okay, y over x, good. Y over x. And then now you pull out t, so it's actually t times mxy. This is actually homogeneous of degree 1. So many steps to do it, but this is homogeneous of degree 1. And then now you do ntx ty. This is actually, the function is minus x. So when you plug in, it's actually minus tx, which is easy one, is t times negative x, which is t times nxy. Also, this is homogeneous of degree 1. So once you show that both are homogeneous of degree 1, so the differential equation is homogeneous. Okay? Then the differential equation is homogeneous, and once it's homogeneous, you let y equal to vx, it's gonna turn to separable equation, and then you can solve for it. It's a routine work, it's tedious. That is why I don't want to give you on the real test. It's like, let's do take home one, because I expect everyone can do it. If you watch a clip and then you follow the step, should be good. This is going to be your free 10 point for this class. For the take home, it's not hard. It's like the same level of this one.
So if I watch the video and like it should be alright.
For that 10 point, yes. But okay, so let's solve this one very quick here. So we have this equation. Everyone, we're gonna take this equation to next page. Okay, sounds good. We're gonna take this equation to next page, and then now we're gonna do y equal to vx. Remember, this is the same thing with dy equal to v dx plus x dv. Okay, same thing. We're gonna turn everything to x and v now. So x cosine y, it's gonna be vx. Y, it's gonna be vx. Okay. Everything looks good now on the first term because we change y to vx. So the second one, we're gonna change y to vx. Dy to v dx plus x dv. Okay, this is claimed to be separable equation already, so you just need to solve for separable equation. But let's see if you can cancel something. So you can cancel this and this for sure. So it's gonna be x cosine v plus Vx dx minus Vx dv, right? And then minus x squared dv equal to 0. Okay? Better? This way. And then now something cancel actually, because if you expand the first term, so x cosine v dx plus Vx dx, you have Vx dx here as well. So this is actually not that tedious, because this and this gonna cancel out. You're gonna have only the term left. You have x cosine v dx. You can move x squared dv on the right hand side, so the sign gonna be plus. And now you move everything around, so you have x over x squared dx here. You have 1 over cosine v dv here. And then you integrate it, 1 over x dx sec v dv. You integrate it. And because of integrate sec, you need a formula. So it's gonna be log sec and tan. Log sec v plus tan v. You can look up at the formula, because it's just not going to be the easy one that you can memorize. And then integrate 1 over x, you get log absolute x. Once you change v back to y over x, that is your answer. So sec y over x plus tan y over x plus c. This is the answer, general solution.
You have to shift the log of x to the g.
No, you don't have to. You can stop here. This is the general solution for this question, so you change v back to y over x. Already good. Again, one more time. So this is a very quick course on differential equation. So the full clip, the full description about homogeneous differential equation gonna be on your clip.เนี่ยพอ10:50มาครบกันแล้วเนี่ย Okay, so before we having a quick break, so let's trying to make sure about the I'll tell you the solution on the, cause I grade the exam, and then I feel like one question that people have a hard time with is like checking the convergence and divergence of no, this one is like make it more, everyone make it more harder than it should be, like log k over square root k plus k. Is that way too hard?
Oh shit.
This is like part D, question 1.
Exactly. Log k.
This one, cause I like some of you like say that this is AK, and then you're trying to do limit comparison test, some of you, which is okay to do it, but I mean, first student, you pick BK to be 1 over square root k plus k. Good choice actually, but this is not a P series, so this is hard, a little bit hard to figure out it is convergent or divergent. But when you do limit AK over BK, and then you say, oh อาจารย์ครับ this is actually limit log k over square root k plus k, and then you do root k plus k here, and then you cancel and then you get infinity. It is actually correct. And then this is infinity, and if you can claim that this thing is divergent, so you're gonna get full credit. But I mean, some of you don't know how to do this. So if you pick, some of you pick 1 over k, 1 over square root k, this is not a good choice if you pick 1 over square root k, because if you pick 1 over square root k, it's gonna be square root k here, and your limit you're gonna get 0 here. And because this is divergent, and this is 0 you're gonna get no conclusion because it does not work that way but some of you pick b k equal to 1 over k smart this is good because you're gonna get log k over square root k plus k times k here and then you're gonna get the limit be infinity and this is actually divergent so you're okay so you are okay with this one if you pick this one good if you pick this one not good well I show you this one because like lot of good student you miss this question because you pick bk equal 1 over square root k but like some student can do 1 over k easily like you know like 1 over k is like the smart move for this one
อาจารย์มี partial credit ให้หรือเปล่าครับสมมติว่าทำผิดแต่ว่าเราก็เขียนวิธีที่เราใช้
partial credit จะได้ถึง1 เต็ม 5นะ
ผ่าเชี่ยวจริงๆนะพี่น้อย
ไม่แต่ว่าคนที่เลือก1ส่วน k ก็มีเยอะนะ
ว่างเลยสัตว์
เลขที่1ก็เลือก1ส่วน k จำได้เลขที่1น้องเคนก็เลือกมีหลายคนที่แบบว่าที่พวกคะแนนเยอะๆจะเลือกผิดแต่พวกคะแนนน้อยจะเลือกถูกกว่า ก็เลยงงว่าข้อนี้แบบว่ามันงงไงแต่ว่าวิธี the solution that I want you to do actually is not limit comparison test actually I want you to do log k is actually always bigger than 1 right when k greater than 3 and then you over this gonna be over than it's gonna be greater than this right and then this one gonna be bigger than k plus k right because square root k just less than k so this one so this is actually bigger than 1 over 2k but this one is divergent so by comparison test this one is divergent as well actually I want you to do comparison test because if you can compare this to this and then this compare to this it's gonna be this and this is divergent so this is divergent but like I don't see anyone using comparison test like I mean some of you use I think the student number 4 or 5 or something you use comparison test and then you use limit comparison test one more time which is okay as well you get full credit but most of you do limit comparison test but if you pick bk to be this one not correct yeah easy one gets hard when I don't know but it's okay yeah I mean like question 1a 1b 1c like most of you like get full credit which is good yeah good one it's just only the hard question that you miss it yeah okay so we're gonna have a break and then we get back 11:05 and then we're gonna learn about 30 minutes more okay so short break to 11:05 ครับwe have 8-minute break so you gonna get the exam back next week yeah on Monday I need Saturday and Sunday to grade it and then Monday you gonna get back
so on Saturday Sunday get coming อ่ะ
มันคือวันอาจารย์จะบอกคะแนนวันจันทร์หน้าใช่ไหม
ใช่ครับ
อันนี้คือต้องมากับตุ้มมาแบบ
ก็ถ้าไม่บอกก็เห็นในระบบแหละแต่ว่ามาเอาข้อสอบคืนด้วยเพราะว่าก็จะให้ดูด้วยว่าผิดตรงไหน
มาเข้าคาบอาจารย์ไม่ทัน
อ๋อถ้าไม่ทันก็ไม่เป็นไรก็เดี๋ยวมาเอาวันอื่นก็ได้แต่ว่าเอามาทุกเรื่อยๆถ้าอยากดูข้อสอบว่าผิดตรงไหนนะแต่คะแนนจะเห็นอยู่แล้วในข้อสอบ
มันง่ายจนคิดไม่ถึงนะ
ก็จะบอกอ่ะ
ทำนานเลยใช่ไหมข้อนี้